Hello, Berlin. How are you doing? Everyone excited? I'm glad that you stayed, although testing is a very interesting topic. As you heard, I have a passion about testing. But I hope that you will enjoy this talk as well. I want to take you on a journey to November 2017. What was happening then? What was so important? Well, we were waiting for air power. It was just around the corner. And Despacito was everywhere. You couldn't just not hear the song. But meanwhile, I was switching companies as well. So I joined this company, iZettle, as Sabina said. And this marked a change for me personally. So I switched from working in a feature team to working on kind of platform team. So I had to zoom out and take more holistic view of the system. And when you do this, you recognize that you start caring a lot more about consistency and maintainability. Luckily, my colleagues already thought about this, so there were a lot of nice ideas that they introduced to me. And one of these ideas is actually the building block behind this topic that I'm going to talk about today, declarative presentations. But before start, we need to talk about declarative, because it's a vague word. So let's establish a common understanding what declarative means. And I'm going to do it in comparison to imperative programming, because they're both programming paradigms, and it's easy to understand that way. A little bit of documentation or kind of definition. This is my way to define it. So imperative programming is a lot about instructions. You give your program instructions, how to execute stuff, and you need to know how the system works. So today I'm going to talk about UI. Let's take UI view and UI view controller as examples. If you want to write code with UI view and UI view controller, you need to know how they work. You need to know their view lifecycle, you need to know the state transitions and stuff like this. So you need to know how the system works. In comparison, declarative programming is about stating facts. You say how your app needs to react to changes in the system. And then you just hope that the system calls you. Let's look at an example, maybe it will become more clear. This is an example I chose for like a view layout. I'm adding a button to the bottom of another view. And what is going on here is like the imperative code should look very familiar to you. There are a couple of things to highlight though. We are using bounds, and we need to know like how frames and bounds participate in the layout, and none of this is rocket science, but you need to kind of learn about it. And for example, on Mac, the origin is at the bottom, and you need to think about this. Also, you need to know where to put this code, because if you just execute it once and then you rotate your view, your button will be misplaced, so you need to know exactly in what method to put it. And a little bit more declarative approach to this will be to use auto layout and to use anchors. And in this example, what is happening is that I'm just defining how my view needs to look in relation to another view. So it's kind of self-explanatory, it's easier to understand, and it will work always, like when you rotate and stuff, it's always true. So you say, my view should look like this in comparison to this other view. And the lower you go, I mean, this declarative approach is not implemented just in a magical way. It's also implemented probably in an imperative way. So they're both connected. But it's nothing new. I think the reason why nowadays we are seeing more declarative stuff from companies like Google and Facebook is that like, the mobile development is maturing, and we start having like nicer APIs on higher level and have systems that can provide us this ability to trust them. They will, like, we just state the facts and they will run what we want. Where are we in this journey? Well, there are some speculations about Apple releasing something, maybe called Amber, maybe not, soon. And if it happens, I will be like this kid, pretty happy. But let's look at the reality right now. UIKit still encourages pretty imperative programming style. And if you liked any of the stuff that I said before about declarative programming, you might be thinking, I want to use that. What should I do? Should I rewrite UIKit? Is this what this talk is going to be about? I will not encourage you to do that. I think we can have both things. You can still use UIKit, but you can have the layer where you interact with UIKit to be tiny and have this kind of wrapper around it, like we wrap this nice, cute dog. Yeah, and then use it with other declarative code. Now, I hope we're on the same page about what I mean when I say declarative. And the plan for today, my plan is to share with you the concept that fascinated me to think about declarative presentations when I joined iZettle. And I'm going to show you how to apply it. There will be live coding, which is absolutely terrifying, but it will be great. And, and then I'm going to show you how to do more advanced stuff with it, the concept. So think about presenting a view. Why do we present views? Why do we present screens? We want our users to do something with them, right? We wait for them to do some interaction, and then our app reacts to that interaction. So we show something, we wait, and then we react. So my colleagues told me, you know, view presentations, Nataliya, they really look like any other asynchronous operations. I was like, oh, yeah, maybe that's true. So I started going to some examples and yeah, showing an alert. I wait for the user to press a button, and then I get accept or not. Then showing something more complicated, like a login flow. I show the login flow, and there might be many, many steps in between. But what I care about is that I will get that authentication token. I don't care about where they go exactly. So what does this mean? It means that we can have declarative interfaces for view presentations, and we can combine them with other declarative code if we start thinking about them as asynchronous functions. And so that you kind of see how you can get to this realization and how you can use it in your own app, we're going to build one now. And it's going to be a point-of-sale app, of course. I'm working for a similar company. We're going to build one that is more Berlin optimized. So, you know, I was thinking what kind of point-of-sale app to build. And then in Berlin, there are all these Späti shops. They sell anything that you can think of. So I'm thinking about bringing digital payments to them. Maybe. So yeah, we're going to have a shopping cart where we add products, and then we're going to initiate checkout to pay for this product, and then some magic happens, we get a receipt, and we can do this again. All right? It's time. I'm going to switch to Xcode now. And I need to mirror. And we are good to go. So how is this going to work? Yeah, first, when I start writing some code, you will tell me if it needs to be bigger. We can adjust it. So I'm thinking to do 4 steps. And the first step, we can start with kind of building the skeleton of this app, because we know what it's going to do. And I prepared a little bit of code that I'm going to walk you through. Right? Good stuff. 50 lines of code. I'm going to walk you through. It's basically not very interesting to show you these, how I implement structs, right? All right, so we have a couple of models. We have a product that has a name and a shopping cart that has products. Is the font size okay? Yeah? Okay. And then we have a receipt and a helper to create a receipt from a shopping cart. Pretty straightforward. And then we have this application flow, which is our point of sale app, which will have the pay method, which is the most important method here. And it's going to drive this payment flow. So we are starting a payment, and then we expect to get a result. I'm also using the Swift5 result type as Glenna. So payment happens like this. You get a shopping cart, you get a checkout flow that we're going to start, and after the checkout flow finishes, we are going to work with the results. So if we get a receipt, we store it. If we get a failure, we just propagate the failure. And then checkout flow. So checkout flow is this thing where you can have many steps and like choose payment and stuff. But our simple application right now will do way less. So it's going to just return always success receipt. And we are going to start the point of sale. So now if I run this code, nothing happens because I'm not using it, but it compiles. So I'm going to add a small demo to this. So we are going to sell, like we are going to create our point of sale app. And I'm going to just return a hard-coded shopping cart with some of my favorite products to buy from Spatty. And and then we're going to start the app. So let's see how this goes. Yeah, we got a receipt printed because our store receipt method is very naive, and it prints the receipt and always succeeds. But that's a good start for us. So this is step one. Everyone following? Yeah? Good stuff. So I told you we are going to build some UI, and I show you these methods, and you might be thinking, yeah, but how do we connect the UI to this? Like, I talked about asynchronous operations for presentations, and this is very synchronous now. So if you see, like, I start payment, and it immediately completes. So this doesn't reflect the reality of how UI works. So we're going to make it asynchronous. So this is step two. To make it asynchronous, I'm just going to switch these result types for all of the things that can take time, potentially, to a future result. So this is something that will happen in the future, and we might get a result. Now, future result is not part of Foundation, and we don't have like a lot of built-in options like futures and promises, but some of you might be familiar with them. And I'm going to show you how you can implement your own future result, like kind of naive approach again, but there are a lot of resources on this topic. So this is less than 40 lines of code, future implementation. I'm going to hide this bottom. The main idea here is that it's generic over value, so you can return any type of value. And once you initialize it, you know that this is exactly the type of value that will be kind of emitted by this future. And you can observe it. So this is where you add your callback. So it's pretty much closures, but with a nicer interface that allow you to pass them around. I'll share the slides immediately after this, and I put all this on GitHub. So I added some like links and stuff that you can read if you want to implement your own type. But it is nothing scary. Like, this is 40 lines of code, and if you want to implement your own asynchronous result type, it's probably just a couple of files, few files. So let's use this result type and change our code. So I'm going to start by changing the pain method. And now we need to return this future result. So let's create a future. we need to specify the type of the future in the beginning when we create it, because we are not passing any value in the beginning, so it doesn't know what we are going to signal. And we can return immediately this future. And the nice thing about the future is that now we can have a synchronous operation and we can complete the future afterwards, but we can still return it synchronously. So let's see how we can do this. Now our checkout flow as well will be asynchronous. So let me make the change here as well. I'm just gonna copy this. And this time the future will gonna return a receipt. And I can return it immediately again. And I can also complete it immediately because we already know that our checkout flow is super dummy and returns receipts like this. So complete with receipt, boom, checkout flow is asynchronous. And now we need to handle it here. So instead of just calling start and expecting a result immediately, we'll get a future, so we need to observe that future. And this is the callback that we get. So I get a checkout flow result, can just copy paste. This code remains the same. We're just adding a little bit of delay here. Right? And I pasted the future at the top because we will need to complete it from this block of code. And in the case of failure, we get an error, and we can say future reject with error. And in case of success, we need to store the receipt, and after we store the receipt, we can complete the future. So I can do observe here, observe, and I can complete the future. Right. So now we are working with synchronous checkout flow. We observe it, we wait for the result, and we store the receipt, like we do a bunch of stuff. And let's see how, if we run this, we need to just change our last initializer here. So this is going to return immediately just as before, but with a new type. And now that I run this, I want to see the same thing, because even though I added a new type, I haven't added any delays yet, so it should just run as before. And luckily it does. Great, but 4 steps. So this is step 2. Now we need to connect this to UI, and we have all of the work done, so we can just connect this to some interface. Today, this talk is not about building interfaces, so I'm not going to focus on this, focus on the presentation flow instead. So that's why I want to use one view controller subclass that has only one button, really. So call it action view controller, and it has an action, right? And then I just add it, and you can get a callback when the action is executed. So that we are able to focus on where we're heading. Right, so some UI. I'm going to add 2 screens. First, I'm going to add a screen for when you enter the app, kind of to trigger pay, so it will have a pay button. And then I'm going to add another screen for the checkout when it completes, to kind of get the receipt. So these are going to be our 2 screens, and I'm going to add them here and here. And in the point of sale, I'm going to return a view controller. And see, so far we haven't used any UI kit, but we still expressed a lot of the logic of the app so far. So I'm going to import UI kit and playground support, because we would like to see this UI actually working. And here we go, UI view controller. I'm going to create this action view controller that I showed you. So action view controller with the title pay. And we want to distinguish, I'm going to use the same class for both, so just to distinguish which one is which, I'm going to use background color. And now we get this asynchronous thing, so when the button is pressed, we can now trigger the action a little bit later. And I need to return the view controller. And action. action view controller. So this allows us to say here playground support, playground page, current, and we can assign a live view, which can be a view controller or view, so that we see what we are presenting. But I also want to add one more view controller, because right now if I run this, it's just the first screen. So we see, yeah, we have a button pay, we press it, we print, but I want to show another screen. So let's do that. And in the star method here, I'm gonna return not only the future, but also a view controller, like this, and create one in a similar way. So get view controller, this time we'll get a receipt, and this one maybe yellow. Yes, I get excited. And yeah, we need to complete the future when we press that button, and we can still return it synchronously like this. But we also need to return the view controller now. Cool. So now we have the both screens. They're created. They're returned from the two places that we needed them. And I just need to change the call side, because now we get a view controller in addition to the result. So let's do that. Let's get a checkout view controller and a result. And the observe method we can call directly on the result. So now this should compile, but we have one warning. And we have a warning because I'm not doing anything with this view controller. And I really want to present it with a model presentation, but I'm in this pay method right now, and I actually don't have any access to UI. Which is pretty good, by the way. Like, I really like that this method so far didn't have to do anything with UI. So I'm trying to keep it that way. And instead of like passing the parent view controller, I'm gonna actually inject a function that will allow me to present the view controller without knowing anything about UIKit. So let's write a function here, present checkout flow. And it will take a checkout flow and will return me the result that I care about. So it's going to be a future result of the receipt, an error. Right? So now I don't need to start the flow. I can just call this function, present checkout, and pass the checkout flow. And this gives me the result that I'm observing. So everything stays the same in the pay method. But we still need to change the call side to do the actual model presentation. And this is what I'm going to do here. So pay, checkout flow. Yep, glow. Right, so now I can start the checkout flow here. I have access to the action view controller where I can immediately present this checkout view controller. The regular presentation, and then I can return the result. Right? And now I'm presenting model view controller. We don't want to stay there forever. We saw like it's a loop, so we want to also dismiss it, so I can observe the result again. And when I observe it, I don't care what result I get, so I'm just going to omit it, but call action view controller dismiss. This should work, right? Maybe. Let's see. OK, we get the first screen. Now that I press the button, we get the second screen. And pressing receipt prints the receipt. So we added the UI to this kind of flow code. And yeah, let's track back what we've done. We have this pay method that hadn't changed much, but it's now synchronous. It can present the view controller. And we also have this method here that does the model presentation. And I want to take this step further, because this code here is kind of can be repetitive. Like if you're presenting a lot of screens and you just want to get their result and then continue with your app flow, you can do this in a nicer way. So I'm going to extract this to an extension on UIKonf where I can create a function to present. And I'm going to start by presenting just the checkout flow, but we're going to make it a little bit more generic. Just in a second. So yeah, presenting the checkout flow gives us this future result of receipt. And I can just copy-paste the same code. Now we are in a UIKonf extension, so this is actually self, and this is self. And we should be able to call here action UIKonf present, just pass the checkout flow. So that's a little bit of improvement when we look at this code, because we say like, yeah, we just want to present, get the result propagated back. And this method here doesn't have anything, checkout, yeah. Doesn't have anything very specific to checkout flow. I would really like to make it more generic. So let's see where we use checkout flow. We use it to start it, okay. And we also use it to get the receipt type. So let's create a protocol for this and see how we can make it generic. So protocol, we are going to present something and wait for results. So I'm going to call this presentable. And it will have this one method start because we need to have access to this. So I'm going to keep the interface the same as in checkout. Oh, didn't copy. All right. So we have this start method, and we also have the receipt. I don't want to keep the receipt in the protocol because I want to be able to present various different screens. So I'm going to turn this into an associated type and make this generic like this. And now replace in the present method this presentable type. So we're going to present type P that is presentable. And we're going to return a value that's going to be another generic parameter. And we need to specify what this value is. So we need to say that the value is exactly the one that P has. So just make it generic. Now if I implement in the checkout flow, if I say presentable, and it doesn't know what it is, because I need to move it. OK, playgrounds are a little bit weird in that sense. Yeah, I implement presentable. It immediately knows that, yes, it is implemented because you have the start method, and it knows that the value is receipt. And I can change this method present to, yeah, we already made it presentable. Of course, there's a little bit of renaming to be done here, but that's it. We get a generic method where we can present anything that implements this protocol and returns a result. So let's see if this still works. Yes, it does. All right. Thanks for following with me. Now I'm going to switch back to slides, and we are going to see what happened here. If you haven't followed, I'm going to upload the code as well. But let's see where this generic method can take us and what it can allow us to do. So let me switch. And like this. Cool. So we are back. How we can take this further? This is the presentable that we defined. And it has this one generic value. It allows us to cover a big variety of screens and use cases. But at iZettle, we took it a little bit further. It's a little bit more metaphysical, because we added this another parameter, which is called matter. And this parameter allows us to express a lot more things with this protocol. And this ultimately leads to consistency, because we can cover a lot of cases with the protocol. So you can present something that returns a matter, and we generalize the result as well. So the result is not a future, but it can be another type. And we have a concrete implementation for UI presentations that return view controller, which we call presentation. And it is really nice because it doesn't, you don't always have to present modally, right? You might want to push, you might want popover. So yeah, this allows you to add a little bit more context to your presentable and have presentables that can be presented in different contexts in a different way with the style and the options, so unanimated and stuff like this. Quickly going through a few more slides. This is an example how you can use a presentation with a flip-push transition and not just a model presentation. And this is how, like, it's very descriptive, and we don't say that, like, we want to call UI view controller and implement flip-push. We have it in one place and we can reuse it. What is interesting about this example is that if you start using this approach, you can build a lot of tools around it. And one of the tools that we have is that tells you what was presented, how it was presented. It also tells you when it ended presentation, was it delocated, so you can track stuff like memory leaks. And the thing to emphasize here is that if you follow a consistent approach throughout your code base, you can start thinking like, what tools can I build for this stuff that implement the same protocol? So yeah, memory leaks tracking is one of those things, but there are many more. Next, I want to mention testing. As we saw, we've done a lot of stuff without writing any UI code in the beginning. And this is really nice for testing because it makes it easier. So you can have, given the same inputs, you can have the same outputs, so that makes tests really reliable and quick. I'm not going to stay long on this slide. You can go back, but it's just testing a flow that is hard to reproduce otherwise with an error. So you are in full control of that. And this is going to test the logic, but what about the view? So if you're familiar with iOS Snapshot test case or any other framework for doing view tests, you can write for your presentable one protocol that, okay, it's a lot of lines here, but what it actually enables me to do is to write one-line tests for each of my presentables. So that's pretty nice improvement to the code base. And I want to note about hiding complexity, last but not least. We saw this unrealistic checkout flow that has just one step. In reality, you might need to choose payment, and then you might need verification with ID, a lot of steps. But do you need to care about those steps? Like, if you're working on the register or like your app, and then someone else adds an additional step to the checkout flow to support new payment method, well, you don't need. You need to care about the data flow, and as long as it's the same, the checkout flow kind of hides this complexity and allows you to focus on your task. So I started with an abstract idea. Hopefully by this point, you can see that you can have many applications, and you can have your applications as well. It doesn't need to be the examples that I show you. But at iZettle, I want to mention that we took it further, and we use this on a daily basis in a big code base. And we have it in production. Our users are using this for like a few years now, maybe 2 years. So it's working really great for us. There are 3 things to remember from this talk. These are they. Think about why you're showing UI. There might be some need for that and some result that you're expecting. And if you do so, you can try to write a synchronous operation for your UI presentation. By doing this, you can keep your UI flow logic decoupled from the rest, and that makes it easy to follow, like not only for you, but think about your coworkers and think about the people that you onboard. And it's very important to have it like declarative and explicit. And the last point is that it makes the possible user journeys explicit, and it's another point adding to documentation. Right. I'm going to upload the slides and share them on my Twitter, but I have a lot of topics that are related to this that we'll have the links in the slides, so you can read more if you're interested. And I don't think that we have time for questions, but this is my Twitter. I'm going to be around at the social events, so you can ask me questions. Thank you. Am I right to assume that we don't have time for questions? We have time. Great. Do you have any questions? By the way, did you see my cool background and my shoes kind of thing going on? Yeah, I heard that it's a first, but I don't know. No questions? One question.
Hey, thank you for the talk. I have a question. For when you are making this declarative UI, and you mentioned that it's clearer for coworkers to understand it, what I often notice is that when you write these kinds of UIs, it may make the flow clearer, but they often have a hard time understanding the code itself. What is your experience with that?
My experience has been very positive. We do have our own small framework around this, and the whole team maintains it. And I think it's really nice exercise for you as a developer to be able to pick up like a generic framework and to kind of work on it and extend it. It's very small though, so it's not something that is huge like any third-party dependency. We also open source it, so we also have contributions from other people. I think it's pretty nice actually to support your own thing like this when it's small, when it's not like huge and creates a lot of dependencies.
Yeah, thank you.
Okay, question?
Hi,
Yeah?
Thanks for the talk. Really great stuff. I was wondering if you experimented with like creating a custom DSL around like expressing the declarativeness of how things work together.
You mean like some custom operators, or?
Yeah, just like moving the idea even further. Like since you now have your own API of presenting
Yeah,
stuff, maybe making it readable and like more explicit in other ways.
Yeah, this does the job for what we want to achieve without adding like a lot of complexity, as the previous question pointed out. So we didn't take it further, although there were some explorations from my colleagues, like trying key paths and stuff like this. It can definitely be taken further. Like this is something that, as I said, it's an idea and you can experiment with it, and there are a lot of cool stuff that you can do. But we don't use custom operators for this.
Hi.
There was a question here, I think.
Hello? Hi.
Okay, here. Yeah.
Hi there.
Hi.
How does this compare to, say, using something like RX or RX Swift, something that will allow you to compose, say, singles and observables and other things?
Right, they're not very related in terms of like this future result and stuff. You can replace it with any framework of choice, like with RX or with your own, or like their futures and promises. So you can use RX for that part. And then in terms of UI presentations, I've seen only one project that does a similar thing. I think it was called RX Flow. I'm not really sure about this, but it has a dependency on RX Swift, and it does a lot more stuff. We try to keep it like lightweight. So they're not like, yeah, exactly. Thank you.
Hi. It's working. Thank you for a great presentation.
Thank you.
Actually, he stole my question. I saw that you are using observable patterns, so I wanted to ask you, did you use the RX Swift in some of your projects?
Yeah, I tried RX Swift for a little bit, and I was not a huge fan because it's like very big project that it felt like a little bit too much to comprehend. We have a smaller observable implementation that, like, again, we maintain, and it just has the necessary stuff. So really like to stick to the only what's needed, basically. But you can use it with RX Swift, and you can take this idea like a synchronous operation, use whatever tool of choice you like.
Okay, thank you.
I guess that's it. Meet me afterwards for more questions. Thank you. Thank you, Nataliya.